And at last, the epic week has arrived. Welcome to day one of week 6, the pinnacle of this course. You've made it. Congratulations. Let's get going. And as you well know, 2 things are happening to us this week. We are, first and foremost, introducing the Model Context Protocol from Anthropic. And secondly, we are returning to my very favorite, the OpenAI Agents SDK. Now that we've completed our grand tour of frameworks, it is back, and never has there been a better time. And as a quick refresher on the different frameworks that we've explored, we started with no framework at all. We then looked at OpenAI Agents SDK. Then we moved to Crew, which was similar, but somewhat more opinionated and had a lot more construct built on top. But it had that great YAML ability to separate out our prompts from what we worked on. Then we moved to LangGraph, which was the week that caught me off guard, and that I fell in love with LangGraph during the week. And we built the great sidekick. And then last week we got to AutoGen, a much more experimental, interesting, out there week when we looked at AutoGen Agents Chat and also at AutoGen Core, culminating in the Creator project at the end. An out there project, a lot of fun, really interesting, which I hope you enjoyed too. But now we are highlighting the box on the bottom right, the Model Context Protocol from Anthropic. What's it all about? But first, I have a word to have with you. I do suspect that a few people will be joining right now who have been daring enough to jump straight from the beginning of the course all the way to now, because they think this is the juicy part. This is where all of the excitement lies, which is fair enough. It's a free world and all that. You are autonomous, just like our agents. But I just want to put on a quick point there. And for those that have been along for the whole ride, you will be agreeing with me on this. There's a lot to love about what we've covered. I realize that you are impatient to get to the topic of the day, MCP. But bear in mind, in the first week, we go through and we natively work with APIs and tools. And if that's not something that you're comfortable with, it's really important to have that foundation as we go into understanding the ins and outs of MCP. And then secondly, in week 2, we go into the OpenAI Agents SDK, and that is what we'll be using again this week. So even if you're going to skip weeks 3 through to 5, then fair enough. But I do think that 1 and 2 are worth looking at. Even if you look at them quickly, speed me up and have me rattle off through it so you get that sense of it. And if you already know about APIs and tools, then you could just jump straight to week 2. But I do suggest you give that a try. But you can keep going if you insist. All right, and for those that have been all the way through it, you know well how much fun we've had at the projects we built and why it's worth it leading up to this moment. And so for those still with us, it is time to introduce the Model Context Protocol. Let's do this. And first of all, I do believe that it's important in explaining what MCP is to start by telling you a few things that it is not. So first of all, it's not an agent framework. It's not like the other things. It's not like Crew. It's not like OpenAI Agents SDK, because in fact, we're going to be using OpenAI Agents SDK with it. And last week we used AutoGen with it as a teaser. So as you know, it is something that sits alongside agent frameworks, but it's not one itself. And it's not some fundamental change to the way we do things. It's sort of building on stuff that already happens, and it's very much a sort of native approach to things, but it's no real fundamental changes here. And it's not a way to build agents. There's no amount of coding agents that happens with MCP. So what is it? Well, it's a protocol. It's a standard. It's just a way of doing things, an approach, and then an implementation to help you adhere to that approach, to that standard very easily. It's a simple way to integrate things, to integrate stuff that an agent needs with an agent. So that really comes into 3 categories: tools and resources, which means context, the kind of stuff you get from RAG, and prompts, like templates of different kinds of prompts. And out of those 3, it really comes in that order in terms of how much people are excited and talk about this. Tools is the number 1. That is the thing that people are really falling off their seats about, the fact that you can integrate tools really easily. Resources is kind of cool and has meant that it's easier to hook up different LLMs to resources, to suppliers of context. And then prompts I haven't seen that take off in such a big way, but I'm sure that there are people taking advantage of it. But that's the way to think of it. And tools is really where everyone begins on their MCP journey. And the way that Anthropic themselves describe it, as they say, it's like thinking of MCP as like a USB-C port for AI applications, which is why I had that cute picture on the prior slide. It's like a connector. It's like the connecting fabric, but it's like the one universal port that has been come up with, this one standard. That means that all of these different peripherals can be connected into each other for all sorts of different purposes without requiring lots of different cables and agreements and so on. So that is how Anthropic themselves frame MCP, and I've seen a lot of people since describe it that way as well. Okay, so that's what it is and what it's not. And now, one more of these kinds of slides. This is some reasons not to be excited by it. So one reason is, look, it's just a standard. It's a protocol. It's a spec with some implementation stuff. It's not actually the tools. Not only is it not building an agent, but this doesn't actually contain tools in it either. It's just the standard. That's all that MCP is. And LangChain already has a tools ecosystem. We've seen that ourselves. We've seen that LangChain has a thriving community. LangChain has a ton of tools, as do many of the other frameworks, by the way. But LangChain is perhaps, I'd say, one of the most popular, the most popular. And you see that in platforms like AutoGen, you can actually bring in LangChain tools. And so there's so in LangGraph and in AutoGen, you could use LangChain tools. And so it makes it so easy to use them. So there already is an existing community around tool building with a common interface. So it's not like MCP is that much bigger. And let's be honest, you can already turn any function into a tool. Even if you don't want to use things like the sort of decorator helpers that you get with some of these frameworks, you can just write the JSON yourself, like we do in the first week. So you can take any function, whether it's something running locally, whether it's something that runs in the cloud. If you want to have a tool that can read Google Maps, then you just write some code that reads Google Maps and you wrap it in a tool. If you want something that accesses the local file system, same thing applies. It's just, you can turn any function into a tool. So what's the big deal? What's so special about MCP? Well, you know very well that I love MCP and I'm very excited about this week. So you know that this is all leading to the positives. But I do want to clarify what it's not. This is what it is. Reasons to be excited about it. So first of all, sure, you can integrate with things like LangChain. If you're on LangChain or if you're on AutoGen, then use the wrapper. And sure, you can write your own tools if you write all of that JSON, but there's friction there. There's stuff, and you have to be in that ecosystem or using that JSON. And if you write the tool yourself to go to Google Maps, then you have to know how to describe it and what the parameters are. So there's kind of friction to doing all of this. And MCP is a nice, clean, simple, native way of doing it without much gumph, without much stuff in the way or concepts to learn. There's a couple of concepts, but that's it. And once you've learned them, you're done. And so it makes it kind of frictionless, kind of seamless, just to be pulling in new tools. You want some new tools, you look them up, you just pull them in with MCP and that's it. Like LangChain, only not locked into the LangChain ecosystem or needing their wrappers, just across everything, across anything. It is frictionless and it is becoming ubiquitous. And on that note, it's obviously really taking off. It's got enormous adoption, exploding ecosystem. And that in of itself is a huge benefit. It's like a positive feedback loop. The fact that it's doing so well and that so many people are adopting it makes it all the more valuable. It's a network effect would be the startup term for it. And that's one of the reasons why it's so attractive, because as you will see when we look at MCP marketplaces, there are just tons of tools out there. We're thinking of writing some code to look at Google Maps, to pull in the maps and have that be a tool in your product, in your AI app. Well, guess what? There's an MCP tool for that. There's an MCP tool for almost anything you can think of. There's so many of them. So that is in of itself a huge positive. And then, okay, so it's just a standard. But I mean, honestly, HTML was just a standard, and look where that got us. So standards can be very powerful things. Having a shared mindset around a common standard that people all buy into, that in of itself is a huge achievement. And with a player like Anthropic, building it and backing it and promoting it, it's got a lot of momentum. And so that is the reason that it's so exciting. And as always, we begin our new topic with the core concepts. So MCP has three pieces to it, three types of thing, which makes up an MCP solution. So the first thing is called a host. Now, these terms, you're going to get used to them. You're going to hear them a lot. And some of them are overloaded terms that we use in other contexts, like host can mean a lot of things. So just to be very clear, so a host means like a host environment, a host application. And it's something that the most common host that is referred to is the Claude desktop app, which is often used as the host for MCP. And the host represents the place where the application software is running that's going to take advantage of these tools that we're going to equip it with. So Claude Desktop is a typical example. You can't use, at least as of now, the Claude chat, the web-based chat. You have to use the desktop. But another example would be our own agent architectures, our own agentic solutions that we will build in Cursor and run it there. And since I mentioned Cursor, Cursor itself is also actually a host in that Cursor can connect to MCP servers. So a host can also be the Cursor environment. It can be agentic applications that we write, like the one we did in AutoGen last week, and like the one we're going to do in using OpenAI Agents SDK. And it can be Claude Desktop. That is the host. It's an application. An MCP client is something which runs within the host. And there can be many MCP clients. In fact, you need an MCP client for every MCP server, every set of tools that you're going to use in your host, like Claude Desktop. So supposing you wanted to give Claude Desktop access to Google Maps, then you would need an MCP client for Google Maps running inside the host, inside Claude Desktop. If you wanted to access the local file system, that would be another MCP client. If you wanted to look up stock prices, that would be another MCP client. You'd have each of these sets of tools offered by somebody. They would be managed by an MCP client living inside that host. And if for some reason you had a couple of different hosts, you had Claude Desktop and you also had Cursor running some tools, and you also had an agent app, then all three of these hosts would all have their own MCP clients for each MCP server. So now that I've said MCP server, I better introduce that. So an MCP server is the actual process which provides tools and context, or resources is the proper MCP word for it. Tools, resources representing context, and prompts. And most importantly, tools, that's what we'll mostly use. And an MCP server is one particular offering that supplies a group of tools. It might be like a file system MCP server that gives tools that give you access to the file system. It might be a weather MCP server that is able to look up the weather for any given city using a weather API. So these different MCP servers are these processes which can carry out some capabilities, and they advertise, hey, I can do these tools, I can look up these resources, I can give you these prompts, and an MCP client running in a host takes advantage of it. And don't worry, if you're a visual type, there's going to be a visual in just a second. And so, yeah, to give a quick example, Fetcher is the name of an MCP server that can fetch web pages. And the way it does it behind the scenes is it actually uses that Playwright Microsoft product that brings up a browser headlessly without a screen and is able to collect a web page. And so that is the name of an MCP server. And you can configure Claude Desktop if you want to use that. You have to set up an MCP client inside Claude, and that will launch the Fetcher MCP server on your computer as a separate process. And we actually did that last week with AutoGen. That was the thing we did, which I sort of talked quickly through, but we used some AutoGen code to have an MCP client running within our AutoGen agent, and that spawned a process on our box, which was an MCP server that was the fetcher server, and that was able to bring up a headless browser. So hopefully you're halfway following me, mostly following me, hearing these new terms. It's going to be much clearer when we see it visually. Okay, let's do it. Let's look at it visually. The architecture diagram you've been waiting for. And you may have seen this a few times because anyone that's done any Googling on MCP will have seen this. But maybe now that we've walked through the terms and stuff, it's going to become clearer. And then I'm going to point out a few things that are like a common misconception. So you have your computer. That's what that big box there is. It represents your machine, your box, which is going to be an important player here. That blue box there is a host running on your computer. Remember, whilst sometimes people use the word host to refer to a whole computer, in this case, we're talking about like a host application. An MCP host is like an application that could be Claude Desktop. It could be your agent application. It could be Cursor, the application, or many other applications that are able to take advantage of MCP. And then we collect a couple of MCP servers. Maybe the one on the bottom left is an MCP server that's to do with using the local file system. And the one on the bottom right is one that is able to look for the weather using Google's weather API. Let's say, okay, well then within the host, we will need to have two MCP clients because there needs to be an MCP client in the host for every MCP server. And so that's what we have. And really those white arrows you see there, that is what MCP actually is. That is the protocol. It's a protocol for talking from a thing running in your host called the MCP client to a process running outside your host called the MCP server. And Anthropic have given libraries to help build these, but really the MCP protocol itself is just the way that they communicate. And let's suppose we also have a remote server, a box somewhere else. Then that could also be running an MCP server. And you could have another MCP client on your host that's talking remotely to that MCP server that's running on a different server. And that would be another configuration. And so that is also something that happens. So those are the different ways that it can fit together. And now, just before I explain the misconception that some people have about MCP, let me just quickly clarify that you remember I said that box on the bottom right could be, say, an MCP server that's looking up the weather in Google using Google's weather API. Well, of course, what that means is that there is, in fact, another remote computer, Google's remote computer in this case, and we are calling a remote process on that computer to look up the weather, passing in Google's API. So it is going off to another server, but in that architecture, the MCP server is running on our box. So there's two ways that this could happen. You can see there's three different ways. Let's talk about all three different ways. On the bottom left, you've got an example of where the client is on our host, is on our box, the server is on our box, and the work it's doing is happening right there on our box. That is one model. The second model is if you come along one and you see the client is on our box, they always are. The server is also on our box, but to do its work, it's calling out to an external API, like the weather, or it could be looking at your Google Drive, or it could be looking up stock prices, or whatever. There's many, many, many MCP servers that run in your box, but call out to different APIs. But then the MCP server turns that into a tool, which can be used on your host. And then the third model is that model. Now we're moving anti-clockwise. The third model is that model on the top right, which is saying, okay, you have an MCP client on your box as always, and it's calling out to an MCP server running somewhere else. And that is the third model. And so what is the misconception? Well, the misconception is that I think when people hear about MCP servers and they hear that MCP servers are like open source and hosted on various hubs that we'll have a look at, they sort of assume that the architecture is that top right architecture, that most of the time MCP clients are calling out to MCP servers running somewhere else, running remotely, because the word server sounds like you're talking about it running on a remote server. But that's just a bit of a confusion. Most of the time, it's actually quite rare that you deal with remote MCP servers. By far the most common, at least in my experience, I'd shout if this isn't your experience, but almost all the ones that I work with are either the one on the bottom left, either that model or the one next to it. And most commonly the one next to it. Most commonly you're running an MCP server that is calling out to get stock prices, to look on Google Drive, to post on Slack, to do whatever it's doing. It's doing that by connecting remotely. But that connection is happening in an MCP server that's running on your box. That's the most common configuration. And it's confusing because MCP servers are provided online, like they're open source. You go online, and there's lots of them, and people talk about that they host MCP servers. But what they're talking about there is that they make MCP servers available for you to download and run them locally on your box in order to call out to an API, just like that diagram on the bottom, just like that diagram. That's the most common. And there are indeed cases when you call MCP servers running remotely, and we will do one of them this week for sure. So you get to see that and experience it and understand what that's like. But in my experience anyway, that is not as common as the other configurations. And I don't think people explain this distinction often. And as I say, because an MCP server is called a server, you might naturally think that it runs remotely, when most of the time, the client obviously runs in your box, and so does the server most of the time. And so there's one more technical point to make about this, which is worth knowing about. You don't need to know this in any detail, but you'll see these terms all the time. So it's good to recognize them at least. There are these two different transport mechanisms, which are two different ways that clients and servers can communicate to each other. And in theory, there might be many more in the future. The protocol would allow for many different types of ways. But as of now, Anthropic has produced two different technical approaches for them talking to each other. And the most common, and the one that needs to be used, that can only be used locally for the kinds of connections that we've got on the screen right now, the first two yellow boxes, is called Studio, or STDIO, and it stands for Standard Input and Output. And this transport mechanism is very simple. The client spawns a new process, spawns a process to run the server. It launches something, and it connects to that using that process's standard input and output, just uses the STD input output. And that is how it sends its messages and how it gets its responses from that process. And that's you don't need to know that technical detail, but you do need to recognize the STDIO, because when we work with this, you'll see that there'll be the terms like server STDIO that we'll be creating to connect from our MCP client to our MCP server. And so that is one of the two mechanisms. And the other mechanism is called SSE. And SSE is saying that the connection will be over HTTPS. So it's going to be a secure HTTP connection. And the way that data will be sent is by posting. And the way it will be received back is using a technology called server-side events, SSE, which is actually the same technology that's used by AI labs to stream back results when you're using the API or when you're looking in the screen. It's a technique for long-running HTTP queries that allows you to sort of drip feed back data, which is how the streaming works. So SSE is the name of this connection type, and it uses SSE. And it's a type. I do believe that you can use this transport either for remote or for the local ones as well. But you can't use STDIO for the remote ones. You're not spawning a process, obviously. It's in a remote box. So, but generally speaking, what you see is that STDIO is used for the local use cases, the first two here, and SSE is used when you go remote. So we'll do that this week at one point. But mostly we'll stick with STDIO, which is the most common one that there is. Okay, that's enough concepts, enough terms, enough diagrams, enough architecture. I know what you want. You want to see it happening. You want to see some code. Let's go to Cursor. Let's see some code. Let's work with MCP. Okay, welcome back to the lab then. We're at week 2, day 2, and we're going to run some imports and the load.env. And now we're going to import account. This is the business logic class. Nothing to do with MCP servers yet. I just want to show you this. When I import it, it automatically creates a new SQL database with SQLite, because that was in the code at the top when you import. If it doesn't already exist, it creates one. And also, if I get an account that doesn't exist, it creates a default account with $10,000 in it, which is kind. So there we go. This is all a simulation, of course. It's just to have something stored so we can watch trading happening. So here we go, new account called Ed with a fake balance of $10,000, no holdings, no trades, no time series. And we're now going to buy 3 shares of Amazon in this fake simulation. And we're going to pretend that I'm thinking of doing this years ago. And my rationale for doing it is because this bookstore website looks promising. Oh, if only I had had that foresight. So there we go. We buy shares completed. And it gives some details of that, the balance, the strategy. And I should say, actually, there's some code in here that looks up the current share price of Amazon. And later we'll come back and I'll talk about how we do that. Then we are going to ask for a report of the account. And here it is with the strategy, the transactions, the rationale. And over at the end here, there is a total portfolio value and a profit and loss. And you'll notice that the total portfolio value is slightly less than the $10,000 it was originally. And there's a tiny negative profit and loss. And for those that care about this, that want to dig into this, I have made a small assumption, a fixed assumption of a fee that you pay every time that you trade in the form of what they call a bid offer spread. And you'll see that in the code. It's just a very simplistic assumption to mean that every time you trade, you lose a little bit. Okay, so let's list transactions in our portfolio. We have 3 shares of Amazon at that much each. And that is a quick demo of the business logic. The next step is to use our MCP server and see if we can access this directly through the MCP server. All right, so how hard do you think it will be? It's going to be very easy. So remember this params. Params is how you say what it is that you want to do. What server do you want to run? And literally, the command is uv, and the arguments is run, and then account server.py. It's just going to spawn a process. It's going to do it itself. It's going to run this process, uv run account server.py. Okay, now I have this line async with MCP Server Studio as server. So what is MCP Server Studio? So this is a class from OpenAI Agents SDK. And it's basically some code which essentially creates an MCP client and attaches to an stdio server that you want to run. It will spawn that server and then run it and allow us to do something with it. So all of that is simply in this one class. And as I think I mentioned before, this is actually relatively new in OpenAI Agents SDK. And as of just recently, you would have to do that last part yourself of writing the code that spawns the server. And fear not, we will do that anyway, just so you see that side of it. But you don't need to, because OpenAI Agents SDK has written that for you. So this is the client and spawns that service. And then we are just going to call list tools, just as we did for fetch, for all of the other tools that we used last time. This is the same code. It's just 3 lines. We run it, we get the MCP tools, and here they are. Get balance, get holdings, buy shares, sell shares with a description. And then you'll see if we scroll along that there are going to be all of the different bits and pieces to it. So if we now just remind ourselves, if we go to the accounts server, you'll see here is our MCP server. And so get balance right here was one of the decorated functions from our server. And if we go back here, you'll see that get balance with that description is exactly what has been surfaced here. And so it really is that straightforward. Okay, so we've seen how easy it is to list the tools. Now let's use them. So it really is going to be, again, very straightforward. Writing MCP servers is a little bit of a few extra decorators here and there. Using them is a cinch. So here's some instructions or a system prompt. You are able to manage an account for a client and answer questions about the account. My request, my name is Ed. My account is under the name Ed. What's my balance and my holdings? Model GPT-4o Mini. That sets us up. And so here it is. This is the code. With MCP Server Studio, that is the OpenAI Agents SDK thing, passing in the parameters of our server, caching the tools, why not, as MCP server. We don't need to do this particularly for one call like this, especially to show you how simple the code looks. So we create an agent called Account Manager. We give it the system prompt, the model, and we pass in the server, the MCP server that we want to use, which is our MCP server, our very own homemade one. And then we put in a trace and we say runner.run with the agent, and we pass in our request, and we'll display the final output. The question is this going to work? What it's going to do if it works, it's going to create an MCP client, which will then spawn an MCP server. It will basically call uv run account server.py, launching that process. It will talk to that process using standard input and output, and it will collect the tools. It will pass those tools into our agent by constructing the JSON gumph that will go in. And when the LLM says it wants to use a tool, then this code will then run that using standard input output to ask our spawned process to run that tool. And then the results will come back and be given to the LLM, which will complete. So there is a lot of stuff happening backwards and forwards that's all been elegantly wrapped into this. Will it work? Will we find out our holdings in natural language from asking GPT-4o Mini based on our very own server? Yes, we will. Your current balance is 9,470. In terms of holdings, you have 3 shares of Amazon. That is mission accomplished. And now, as it says, we are going to create our agent using these tools. So you may remember that when using OpenAI Agents SDK, instructions is what they call the system prompt. So we're going to say, you browse the internet to accomplish your instructions. You are highly capable of browsing the internet independently to accomplish your task, including accepting all cookies and clicking not now as appropriate to get the content that you need. If one website isn't fruitful, try another. Be persistent until you've solved your assignment. Try different options and sites as needed. Okay, then I've got this as before. So this is going to create an MCP server, an MCP client, and an MCP server for file management, with passing in the file parameters. And then the same with the playwright parameters. So we now have a bunch of these different sets of tools. I'm using a parameter cache tools list. And as OpenAI explains in their documentation, that just means that every time you call an agent, it's not going to re-go and re-establish the tools, but it will remember them. So that's a sort of a best practice if you're using a service where the tools aren't going to change all the time. So we're then going to create an agent. You remember this agent? We give it a name, investigator. We give it some instructions, which is the system prompt. We give it a model. We'll use GPT-4o Mini. And this is new. Lo and behold, we're not passing in. We could just pass in the tools that we already got earlier on, but we're not going to do that. We're going to pass in these MCP servers that we have that we've created, one for files and one for browser. And we are passing them in as our MCP servers to use right here. And then with trace investigate. So we're setting up a trace called investigate. We will then call runner.run. If you remember runner.run, it seems so long ago that we did this, but runner.run, which is the OpenAI Agents SDK way of sending a prompt to an agent. I'm going to say, find a great recipe for banoffee pie and then summarize it and write it to banoffee.markdown and print the final output. What do you think? Is it going to be this simple to have hooked up 2 MCP servers, one for browsing the web, and it's going to try and run it in a browser, and one for writing a file? So it's off and running, and it's thinking about what it's going to do. And up comes a browser. I can see it's looked for banoffee pie down there. We'll give it some time to think it through. And there we go. It's finished. It has announced it's created a markdown file for the banoffee pie recipe. Do you know what banoffee pie is? If you don't, it's delicious. It's I think it's English. And hopefully this recipe will give you a good way to do it. There we go. We've got our banoffee pie recipe. It got there, of course, by surfing the web and by writing files. And it did that by spawning two different processes on my computer. One of them was an MCP server for file management. One of them was an MCP server for browser management. It spawned them by running these commands. For browser, it was running node for this. And for the file management, it was also running node with this server file system. So it ran both of those programs and then it communicated to them. But it did so just by providing tools to the LLM to select from. So all of that happened. It followed this entire workflow. And if we look in my sandbox directory, no surprise, there is indeed a banoffee.md. And if we bring that up, we have a banoffee pie recipe that has been written to my hard drive through the MCP server file tools after searching the web using a browser that it spawned on my computer. And that is our inaugural use of a couple of MCP servers running locally. I hope you are impressed. And you may remember that OpenAI Agents SDK traces what you do because we wrapped it in a with trace when we called this right here. And as a result, we can go to the OpenAI platform page and look at our trace. And here it comes. The investigator is what we called it, and you can take a look through and see how it calls the MCP tools for both sets of MCP servers, and then it makes use of both the browser tool and the file tool, and you can look through the trace of how that happens. All right, so just in case you weren't super impressed by that, maybe you found it anticlimactic, let me now reveal what it is about this that makes it so exciting. It's about the community of MCP servers and how easy it is to access a massive, diverse array of different MCP servers out there and just drop them into your project. So here, for example, are some MCP marketplaces, which are just sort of hubs where you can look at different MCP servers that people are offering. And MCP.so is one of them. It's a place where you can find awesome MCP servers, and it has 7,200 of them right now, and maybe more when you look. It includes the Playwright MCP we just looked at from Microsoft, but you'll also see a bunch of others here, something that connects to Blender, Perplexity, something, let's have a look. Let's keep going for something that looks interesting here. GitHub, Fetch is one that we know, of course. There's something that will look at the time and time zone. That's a simple one. A file system one we know about. Slack, GitLab, and lots of other useful MCP servers that you'll see here. A weather one to the example that I gave before. So much to explore. So you should come in and look at some of these. There's another one called glamour.ai, which has a ton of these MCP servers as well. This is very popular and it rates them for security, license, and quality. And so it's a good way to look at them. You'll also see there's a way to filter down for the ones that can run remotely, of which there are just 400 out of their, is it 3,000 that they have here? Yeah, 3,300. But that gives you a sense of what it's like to use a remote MCP server. But there's lots of stuff here to look at. And to show you one more, Smithery is a popular one. And here it has it, 4,000 MCP servers available here. And any one of these, if you come into them, let's find out this memory bank one here. You'll be able to read about what it does. You'll be able to read about its tools. That is another example of how you can use these. Let me show you if we're on something like MCP.so and we go into the Playwright MCP one right here, up it comes. It gives you the full description of how to use it here as well, and you can flip over to see the content. This is how you would configure it. So this is the command and the args exactly as we specified it in our code, and here are the tools that it uses. So this gives you such a simple way to navigate around a MCP server marketplace. And then finally, I have a link to a great article, a blog post in Hugging Face community blog by someone that talks about the MCP server marketplaces, why they're big right now, how MCP works, why it's so huge. And this is well worth a read. And there's another blog post I like that lists out a bunch of different servers that's also worth looking at. So do take a read through these. I already did. Sorry. This is the MCP libraries. This lists out mcp.so and Smithery that we just looked at, and then a bunch of others that are all worth checking out. So yeah, two links to Hugging Face. The first is the top MCP servers. The second is a great community article that talks about what makes MCP so popular right now, what there is to love about it. But I hope I've given you a good impression. It's not necessarily that just connecting to one MCP server is going to necessarily show you the power of this. It's about how many of them there are, how easy it is just to drop one in with the parameters that you set. Just like this, you set the parameters, and then you can just use an MCP server. It will run typically locally on your box and give you access to a new set of tools, potentially tools that it's calling to the cloud to do if it's looking for the weather, but they're tools that are typically running locally on your box. And that is MCP. And that concludes the first lab of the first day of week 6. And if you're thinking it's a bit of an anticlimax, is that all it is to MCP? The answer is yes, and that is the point. That is all MCP is. It's really simple. It's really easy. It's a few lines of code, and then you suddenly have access to a new set of tools that somebody else wrote. And there are thousands of these tools that you can bring them all in. And during the rest of this week, indeed, we'll work with a zoo of different tools, and we'll take great advantage of all of them. And that's what makes it so exciting and so fun. And it's partly because it is so simple. And with that concludes the first day of week 6. And tomorrow we will get into actually building our own MCP server and building our own client. And it's going to be great.